Item 5. So item 5 has, the scenario is a new road, which is our road 1, is being constructed in Kampala, represented by the equation y is equal to 2x plus 3. This is road 1. It will intersect an existing road, which is road 2, represented by this equation. A traffic light needs to be installed at the intersection point of those two roads. Another planned road, which is road 3, needs to be parallel to road 1 and pass through the point 4,1. Then a fourth road, which is road 4, must be perpendicular to road 2 and pass through the same point 4,1. The task is calculate the coordinates of the intersection point of road 1 and road 2, where the traffic light will be placed. So we have to find the coordinates of intersection. Then determine the equation of the line representing the planned road 3 and road 4. Equation of the line. Calculate the acute angle between road 1 and road 2 at the intersection point. The answer should be in degrees. So what do we interpret from this? We have road 1 is of this kind. We shall say this is road 1. Then this road 1 is intersecting road 2. So I'm going to say, let's say this is road 1. This is road 1, this is road 2. And that's how they're intersecting. Then it's stated that road 3 is parallel to road 1. So if road 3 is parallel to road 1, it means that maybe it's this kind structure. So this is road 3 and it's passing through point 4,1. Then we have road 4 being perpendicular to road 2 and passes through the same point. So I'm going to draw road 4 there, perpendicular to road 2. So this is road 4. So this is it. But road 2 is given to us. This road 2, the equation is 3x plus 2y equal to 12. Then road 1 is going to be y equal to 2x plus 3. So this is rod 1. Now the first assignment is to find the point of intersection of the two rods, rod 1 and rod 2. Whenever you find questions asking for intersections of two lines, just know you're going to handle these two lines as simultaneous equations. What you have to do is to handle them as simultaneous equations. So I'm going to use substitution. Why? Because rod 1 is a bit simplified. It's having y equal to 2x plus 3. Then the other equation is 3x plus 2y is equal to 12. So I'm going to substitute this in the position of y there. So it's going to be It's going to be 3x plus 2 open to x plus 3 is equal to 12. So 3x plus 4x plus 6 is equal to 12. When I move this 6 there, it's going to be 12 minus 6, which is 6. Then 4 and 3, that's 7, giving me 6. Divide through by 7, you end up with 6 divided by 7 there. That's the first point, x. After getting x, I'm going to use this very equation here to find the value of y. So y is equal to 2 into 6 out of 7 plus 3. It's going to be 33 divided by 7. So the coordinates are going to be 6 by 7, 33. This is where they have to put that, what are they going to put at the junction? They have to put that traffic light at that point there, the point we have. So we move on to task B. Determine the equation of line represented by rod 3 and rod 4. So we have rod 3 passing through point 41 and it's intersecting rod 2, but it's parallel to rod 1. So I'm going to use that parallel concept. Parallel lines have the same gradient. If line 1 or if rod 1 has this equation, y equal to 2x plus 3, we know very well that this is coming from mx plus c, where m is the gradient. So here our m is 2. That's the gradient for R1. This means that if R3 is also parallel to R1, the m is 2. But this line is passing through points 4 and 1. So how do we generate this line? Some people use this formula and struggle with finding C. That one's the longest route. It's a longer route. Take the shorter route. Just y minus 1 point x minus 4. So this is the formula of finding the gradient. Change in y over change in x is equal to the gradient. So take this, that side. It's going to be y minus 1 is equal to 2x minus 8. Then I move that 1, so it's going to be y equal to 2x. So negative 8 plus 1 is negative 7. This is the equation. I've multiplied 2 throughout x times 2, 4 times 2 to get to x minus 8. So this is the equation they want us to find for rod 3. Then rod 4. Rod 4 is perpendicular to rod 2. Perpendicular lines have this property. If my rod 2 has the equation 3x plus 2y equal to 12, it means that if I'm to make y the subject, at this point it's going to be y equal to 2y is equal to 12 minus 3x, then divide throughout by 2. It's going to be y equal to negative 3 divided by 2 x. 12 divided by 2, you end up with 6 there. So the gradient here, I will say this gradient is my m1, negative 3 out of 2. So this one is perpendicular to R4. So for R4, my m2 is not known, but I can get it. Since these two are perpendicular, m1, m2 is equal to negative 1. That's the formula we use. So m1 is negative 3 out of 2, and m2 negative 1. So m2 is the reciprocal of that, and you end up with 2 out of 3. After getting 2 out of 3, I'm going to use that very method we used there, changing y over changing x. Since this equation R2 is passing through the same point 4, 1, we shall use that same concept. Y minus 1 is equal to 2 out of 3 into x minus 4. I'm moving this one, 2x out of 3 minus 8 out of 3 plus 1. End up with y is equal to 2 out of 3x minus 5 out of 3. That's our R4. Our rod 4. So this is it. Then we're done with part A and part B. So part C needs us to calculate the acute angle between rod 1 and rod 2 at the point of intersection. what you're going to do, we know that whenever we are finding angles between two lines, we use this formula. Tan theta, whereby theta is the angle we're looking for, is equal to the gradient of one line minus the gradient of the second line divided by 1 plus m1 m2. So this means that tan theta is equal to, what's m1? We saw that line 1 or R1 has 2 as its gradient. So I'm going to use that 2 here as my m1 minus our m2 for R3. Is it R3? It's R2. Our R2, where is our R2? Where is our R2? Our R2 is this one. We saw that it has a gradient of negative 3 out of 2 somewhere here. Our R2 has a gradient of negative 3 out of 2. So it's what I'm going to put here, negative 3 out of 2 divided by 1 plus 2 into negative 3 out of 2. And when you compute this, it's going to give us 3.5 out of negative 2. So we're going to eliminate, or we are going to treat this as absolute. It means that that negative is going to be made inactive or of no effect, such that at this point of finding theta, I'm only going to bring in the positive value of that, which gives us 60.26 degrees. Why? I eliminated this negative sign here because it was going to give us negative 60. So I had to remove it. So this is the angle that is formed. This is our item 5. Item 5 was coming from very many topics and was requiring very many ideas. We have simultaneous equations, we have coordinate geometry. So that's it. Our next will be item 6.